In Chapter 8, we will discuss managing cost and quality, which are two critical outcomes of any project. The learning objectives for this chapter are to understand ways that we can manage project costs, understand the concept of quality and why we should care about it. We will also look at the history of quality management and its pioneers and the standards and certifications that exist today for quality management. And finally, we look at tools and techniques for managing project quality. The case study in the textbook covers the efforts around driverless cars. This is a technology that its safety, which of course is a key quality measure, is extremely critical from public's perspective. And a single accident of driverless car significantly delays the industry's efforts in introducing this technology. So this is just an example of the one particular quality aspect to be so important in an industry. And of course, there are many other examples as well, as we will see in this chapter. You remember the triple constraints of time, cost, and scope for projects, which means that changing any of these parameters will require us to re-estimate other aspects of the project to maintain the quality of the project. We have already talked about scope and time in previous chapters. In this chapter, we will focus on cost and quality. Now let's take a look at the elements involved in managing project costs. Like most other project management processes, we need to start with planning, how we will manage the cost. As part of the planning, we need to estimate the various resources required for the project. Based on the cost and required contingency, we can then establish the project budget. And of course, when we have the project budget established during execution, we will compare actual costs against the planned budget, and we will take corrective actions if there is a deviation from our planned budget. This is the process for estimating costs. You see a lot of similarity between this process and the estimating process, such as those we discussed for estimating activity durations in Chapter 7. Reserve analysis is a terminology you have not seen, is really forecasting the contingency that the project will need. For estimating a project cost, we need to make assumptions about aspects of the project about which we don't have enough information. It is important to document and monitor assumptions so that those assumptions, if they prove to be different from actual information that we have later, then we would need to revise our estimates. There are a number of guidelines we need to keep in mind when we are making cost estimates. First and foremost, we need to take the time to break down the project and estimate the costs associated with various activities identified in the decomposition of the project. Sometimes organizations try to estimate projects without having enough information about the project, like in this Dilbert's comic strip shown here. Another thing to keep in mind is that parametric estimating is an effective way to estimate a project based on similar projects. For example, if I figure that I can cover 3 knowledge areas in one lecture, then I can estimate that if I have to cover 22 knowledge areas, then it would take me 7 or 8 lectures to cover all of them. So this is parametric. So I'm using the information about the smaller effort and extrapolate it to estimate the overall effort. And the other thing to keep in mind is that the estimates that we put together are simply forecasts of actual costs, and their accuracy depends on how much we know about the task and how accurate were our assumptions. To take into account inaccuracies that exist in estimates, we add a contingency to our estimates to anticipate that some of our estimates will fall short of the actual costs. In addition to contingency, many organizations also add a management reserve to the project estimate in determining the project budget. Typically, management reserves are controlled by the management over the project manager. For example, in many organizations, project executive sponsor has that management reserve and release parts of that reserve as he or she deems necessary for the project. Now we move to the topic of project quality management, and let's start by defining what we mean by quality. Quality is formally defined as the extent to which the requirements are met. Keep in mind that requirements capture the needs and expectations of project stakeholders. Therefore, quality ultimately is meeting project stakeholders' expectations in the context of projects. Or more generally, quality is meeting the expectations of customers in any setting. That is why systematically capturing customer feedback and acting on them is fundamental to improving quality of any product or any service. My interest in quality goes back to mid 1970s when I came to the US and saw the economic impact of imported Japanese cars, which were much more fuel efficient and reliable than American cars at the time. Fuel efficiency was particularly important to the consumers at that time because gasoline prices were extremely high. When I was at Chevron, I was fortunate to have the opportunity to attend one of Dr. Deming's seminars and became convinced that management based on statistics and data, while particularly paying attention to people, that made a lot of sense to me. I have used the concepts of uh, quality management throughout my career, and I have seen amazing results when you pay attention to customers and to the employees and contractors that work with you. General Electric, GE, defined quality from different perspectives, including those of customers, employees, and the processes in the company. For customers and employees, we can assess how well we are meeting their expectations through a feedback process. For processes, we need to identify ways that we can measure the outcomes and improve the outcomes um, of uh, of the process so that the process consistently produces error-free outcomes. Another example is Nestle's, where they put the the consumer and customer in the center of all their quality efforts and identify key areas where they keep their focus on such things as food safety or zero defect and no waste. A clean room, which is sealed and highly sterile environment, is needed to prevent introducing foreign particles in the process of manufacturing semiconductors. This is an example of something that is needed for a process to consistently produce good results. Some programs, such as those that support air traffic control, have no tolerance for error. Uh, Therefore, quality management is vital for any project in those industries. The quality management movement started in 1950s in Japan after World War II. The most famous pioneer is Dr. Deming, who is referred to as the prophet of quality. Another person, Joseph Horan, is famous for advocating the 80-20 rule. That is, 80% of issues are caused by 20% of processes or people. So it's critical to find root causes of the quality issue and address those. Philip Crosby introduced the concept of quality is free, meaning that all building a quality in the product is cheaper than fixing the quality issues that we may face afterwards. We will look at Ishikawa fishbone diagram a bit later. Kaplan introduced the balanced scorecard concept, where you combine financial, process, or customer perspective and combine them for assessing the performance of an organization or a project. Dr. Deming, in his Out of Crisis book, listed 14 points for quality. Many of these points were contrary to the common management practices at the time, and even some practices now. For example, point 4 deals with awarding contract based solely on the price, and instead he advocates looking at the total cost in the long term. Furthermore, he advocates to build relationship and partnership with suppliers rather than have keep changing your suppliers chasing the lowest upfront cost. Let me share with you an example of how I used points 10 and 11 on a major office building project that I managed while I was at Chevron. Chevron had a very strong safety culture. Uh, so typically, projects promoted the no on-the-job injury slogan and celebrated reaching major milestones such as 10,000 hours of field work without an incident. But when you think about it, no worker comes to the job site wanting to get injured. So construction incidents happen because of unsafe um, conditions on the job site. That's the root cause of many of accidents. So I started a safety improvement suggestion competition where the leadership from Chevron, general contractor, and the architectural firm, we all got together and selected the best suggestions submitted by field workers on how improve the job site safety. For example, if the railing was down on the third floor, someone would report it. The general contractor addresses the issues, but at the end of the month, we look at that suggestion as well as other suggestions that we had received and select the best suggestion to receive $500 cash award. When I announced the program, there was a lot of skepticism among the field worker, and in the first month, we only received a few suggestions. However, after we selected the best suggestion and I went to the field and gave the person who made that suggestion, gave him a $500 check, uh, people got really interested and realized that this was serious, and we received many more suggestions in subsequent months. With those suggestions, we were able to maintain a safe environment for all workers, and we did not have even one on-the-job injury throughout the construction. The Horan's trilogy of quality focuses on quality planning, quality improvement, and quality control, which is very similar to many project management processes um, that include planning, execution, and controlling. Philip Crosby had the concept that quality is free. Uh, let's understand this concept by looking at the two kinds of costs that are associated with quality uh, in a project or a product or a service. There are two kinds of costs. One are the costs of uh, conformance to requirements. That is, whatever we do to meet the project requirements, such as testing or improving the software development process by, say, instituting a peer review process among programmers. The other costs are associated with non-conformance to requirements, such as dealing with downtime costs of the system or impact on reputation of the organization that developed the system. So uh, Crosby's point is that we are better off to uh, to spend money on conforming to requirements rather than dealing with non-conformance issues when the product is released. Establishing a culture of quality management or quality improvement uh, is not easy and doesn't happen overnight. It typically goes through 5 levels. The least effective way to address quality management in an organization or on a project is to be reactive, meaning that we fix the problems after the product is delivered to the customer. This is not only very expensive, but also doesn't leave customers with good impression of the products or services. The next level is to implement some quality control measures so that defects are identified before the product is delivered to customer. For example, we establish extensive testing. The next level is focused on the processes tied to product defect and improve those processes so that we can consistently produce good products. For example, we can establish peer review among programmers to improve the quality of software being developed. The next level is build the quality thinking at the planning and designing of the product, and perhaps through small prototyping. And finally, we reach a level that the organization has a culture and a commitment to a continuous improvement and continuous focus on quality. One of the quality frameworks that is developed by Carnegie Mellon University with the support of federal government is the capability maturity model. This model measures the quality maturity of an organization at 5 levels. The initial level is where there are no consistent processes and the success of the project depends greatly on the individual's ability and skills of the project manager. The next level is repeatable level, is when some basic project management processes are established and followed. At the defined stage, all processes are defined, documented, and followed. At the managed level, the organization is collecting data on its processes and improves them as needed. At optimizing level, continuous improvement becomes part of the organization culture. So this framework captures the same ideas in a very systematic way of assessing the quality in the organization. This framework has been used by many government agencies for selecting their suppliers, typically requiring a maturity level of 3 or more for suppliers. Another very popular quality framework worldwide is ISO 9000, which lays out a set of standards for various management processes such as customer focus or engagement of people. In the US, the National Institute of Standards and Technology, NIST, has established and has managed the Baldrige Award in cooperation with private sector for many years. And you can see the 2019 winners of this award. Project quality management processes include planning, managing, and controlling quality, very similar to many other project management processes. Let's look at each of these processes on this slide. The quality management planning process is detailed out. This is when you establish quality targets and plan for testing and other inspections. One of the effective tools for quality planning is benchmarking, where we compare the performance of various organizations in a particular area. When I was at Chevron, I led 2 benchmarking studies of our capital project management process, and we found out that our projects are costing the company more than the industry average. Um, these benchmarking studies highlighted some issues, and after we looked at root causes and revised our project management process, eventually we were able to save millions of dollars in at Chevron by improved processes. There is an article that you can see, it was published by Financial World magazine, that featured that effort in Chevron. You have a link to it if you're interested to read it. A good quality plan addresses questions such as what, when, and who in terms of ensuring that the quality activities are all identified and assigned to various people. The process to manage quality is detailed out here. We will look at example of checklist. Also, let me point out the term here that you see, design for X, is or design for excellence. It focuses on aspects of product or service where the design efforts focus on maximizing quality and reliability and minimizing cost. So this is an example of building quality in the product during the design phase. This is an example of quality checklist published by FDA to ensure the quality of medical devices. Checklists are good tools for quality to make sure that we have a consistent way to go through and check various aspects of quality. The control quality process is detailed out here on this slide. And let's look at a couple of specific tools for performance review and root cause analysis. Control charts are intended to monitor the outcome of a process and ensure that the process is producing its outcomes within upper and lower limits set for the process. This is an example. This, for example, could be the number of bugs that are found in a system each week. When the process outcome is outside the control limits, then the process needs to be examined and improved. Another technique for examining the performance of a process is Six Sigma. This is a disciplined, statistical-based, data-driven approach and a continuous improvement methodology for eliminating defects in a product, process, or service. It was initially developed by Motorola and Bill Smith in early 1980s based on quality management fundamentals, then became a popular management approach. General Electric with Jack Welch, their CEO at the time in early 1990s. So the idea here is that you want to reduce the variance in the outcome of your products more and more as you improve your quality. When we find issues with a process and we need to improve it, then cause and effect, sometimes called fishbone or Ishikawa diagram, is a good way to brainstorm on causes from the environment, material, methods, or people on that process. After we identify those elements or processes that need to be improved, there are a number of techniques that we can use to improve them. One of these techniques is a systematic review of every step of the process and determining if the step can be eliminated or it can be improved. This is uh, really effective in when you're uh, looking at a particular process and trying to identify improvement opportunities. So when we have identified all the items that need to be improved in the process, Pareto chart is a good visual way to determine what needs to get addressed first. In this example, as you can see, majority of problems are caused by issues 1 and 2. So we will get the biggest bang for the buck if we address these issues. Lastly, when we identify the areas that need to be improved, we can use the model of plan, do, check, act to implement improvements. Essentially, we determine uh, what needs to be improved, we implement the changes, then we check the effects of the change in the outcomes, and we adjust as needed. So this concludes my lecture on chapter 8 of the textbook. Thank you for your attention.